so I thought I would create a tutorial on how you can get yourself a nice simple lighting setup, very similar to this one you're seeing just now. So this is actually using the Unity render pipeline just now, and it's very easy. All we have is a simple fog that is surrounding the environment, and then we have a tile map, floor, some basic objects with specular setup material, and an AI character running around the map to a specific area. Everything here can be downloaded in the description. I'll leave a link to the repository. And on screen now we can see this is the universal render pipeline. This is a perfect style for me to develop simple mobile games and so on. It's got 2D pixel perfect as well, and we can see that it looks the same as the other one, so we can experiment with lighting without having to get too complex into setting up a high definition render pipeline, which is actually not as bad as you may think. So hopefully at the end of this video you have a good idea on how to experiment. So the first thing you're going to want to do is just create a new project, but this is using Unity's built-in renderer. We're going to be using the universal render pipeline, not HDRP, but the skills are transferable between the two. So once your scene has loaded up, be aware that if you are using HDRP, that a lot of third-party plugins aren't really supported right now, and VR development already has a lot of plugins, and jumping between, you can't develop quickly, and it's too scary to upgrade or migrate your project to the latest version of Unity or the latest version of Oculus SDK right now is too risky. So I would recommend just sticking to URP for now. So the Unity version 2020 minor patch 2 is actually going to improve some HDRP optimization. But for now, I'm on .1 and we're going to be using the URP, and we'll get this scene looking nice and good. So the first thing I'm going to do is just reduce gizmos a bit so you can see what's going on. So traditionally in your scenes you just need a light and a camera, but as you can see in this one we have a little bit more. We have reflection probes, and we also have models. Now, I'm just going to get rid of the models for now. We don't need them in the scene. The first thing I'm going to do is actually just create a plane as we previously had. And I'm going to select the main camera, and I'm just going to kind of zoom in a little bit, look up into the distance, click Control Alt F to get the camera into the position that I was looking at. So the scale is quite small on this just now, so I'm going to increase the plane to 10 by 10 by 10, and then just make sure the camera's elevated enough and a little bit of down angle just so we can see into the distance as well. Very nice. So what we can see here in the scene is, now we've disabled the models, we have a main camera, a directional light, nothing new there, a post-processing volumes. Volumes essentially allow you to assign a specific post-processing component to an area if you want to, which an area could be this scene, the area could be local as well, and you can assign colliders to the post-processing effect to occur when you enter that trigger, for example. I'm going to disable all these just now because I don't want to have any post-processing effects on a simple scene. However, if you see here, we actually have a volume profile, and as described earlier on, you can actually just modify these yourself and add in another profile, another override to that scriptable volume profile, and then when you do go back into post-processing volume, you can just assign that same. You can assign one of the templates that has been created before, so you can change it quite quickly. So this is all part of the scriptable render pipeline, so you can customize your profiles to suit what you want. We also have a series of reflection probes. I'm going to get rid of those two. We're just going to focus on one just now. So here's our reflection probe, and you can see that it's actually rendering the sky. And if we look into the scene view, the sky is nice and dark, and I prefer it like that so I understand what skybox we have. And in the game view, we actually have the skybox. So traditionally, you go over into environment, and you can see we have skybox material. This is part of the standard assets that come with this. And you can see we've got skybox procedural here, and we are using a sun with sun convergence, but I don't need any of this for a simple scene. So what we want to do is go up to Skybox and then set it to panoramic, because I don't want to have to create a cube map for an empty sky. But you do have to set this panoramic, and you will be using this material in pretty much every URP project you do. I'm going to reduce the exposure because I don't want it to be too intense just now, and I'll also be setting the sky. Let's just keep it to this grey color for now. You can obviously use a swatch tool and just get it the exact same color as the previous one if you're trying to perfect it, but as I say, the links for the actual project itself is in the description, or follow along. So here we're just going to import some textures I have. These are just prototype textures which can be found in a link in the description. These two Unity packages are just a low poly round and a prototype Unity package I create for these cases. So let's go and create a new material and let's call it floor. And this floor is a lit texture by default. And then what we want to do is assign the base map to, let's go for texture 07 again, which is the same as previously. And then we're going to assign this to our floor over here. As we can see, the tile is only small by 1 there. So let's set this to 25 by 25. Looks good. And if you look in the scene just now, we don't actually have anything that's lighting the scene up apart from this single directional light. And if you disable that, the scene is still kind of lit. This is because we actually have the real-time shadow color set for a start. That needs to be set to a darker color. But we're using the source as a skybox, and if we reduce this, you can see the scene goes very dark quite quickly. However, we can use a color or a gradient to set the sky. Now, personally, I love playing with the gradient. I'm very glad they have this as a source now because I had to write a shader previously. But if we just go into color, and we're just going to set this just to a neutral white gray color, just so we can see some stuff, and ensure that the intensity is not too much on the actual light itself. So let's set that there, and also change the light color just to something a little. Actually, I'm going to change that to white for now so we can just get the intensity. Now you'll notice as well, if you go up to project settings and go to quality, we can see here that the rendering is by default set to high quality universal render pipeline asset. So let's take a look what that is. And as we can see down here, we have a HDR universal render pipeline asset here, which is essentially setting your quality, such as anti-aliasing, your shadows, the post-processing techniques, and the shadow resolution, which can bloat down stuff. So this is fantastic to be able to switch between these, and all you have to do is go into quality and set it rather than this traditional standard ones that you have. You can actually just create your own now. So we're actually going to be using the medium quality one just for now because it's a nice balance between having shadows enabled with low quality not actually including them at all. And here we can see for the high quality one we render the shadows quite high there. 2048 is still not required, so I'm going to change that to 1024. So let's get this directional light enabled again. As you can see, the scene is starting to look quite nice now. We're going to change that angle to 50 and that to 0 just so it's not so intense, depending on the camera rotations. Let me just see. Okay, so let's select the floor and reduce the smoothness. Yeah, you can see if we increase the smoothness, we're going to just turn that down, maybe just something like that. We also have GPU instancing. I like to keep this enabled for floor static objects that won't be moving, such as the floor. And just in case I want to reuse it, it will be there. The material is very generic, it's just a tile map. So our light probe group, let's go take a look at this. So I've double clicked on it here and we can see it's actually being designed to go around objects specifically. So we're going to delete that light probe group and we can see the scene's lit up a little bit there as well. This is because the bake, we're now using real time and also baking the light map to sprite light map sheet. So we've disabled that now, and if we go up to game object and click on light and click light probe group, we'll double click here, we can see it's in the scene. We have a little light probe group. And all this is going to do is allow us to have real-time lighting with reflections, just a little bit more improved to what we were expecting with real-time global illumination. It's just going to look better. So if we click edit probe, select all, duplicate selected, and just drag this out a bit, select all, duplicate selected, and then I'm just going to pull it out here. So this is just a generic box. We can actually change the size of these and see more properties to do with light probe groups by going up to the lighting tab, going on to scene, and then at the bottom here we can see highlight invalid cells, display occlusion, and only used by selection. You can experiment with the light probe visualization here as well. So now we have some of these set up. I'm gonna get the main camera, and I'm actually gonna assign a tag to it, just an orange one, so I can see where it is in the scene. So if I just move this camera angle down a little bit and we just look up slightly, we can see that the distance, it kind of fades out a little bit, and we've got a nice bright floor here. The next thing to do is to go back to our environment under lighting. We can see we have our directional light preset enabled. So if we go to our presets here and go into defaults, we can see we have our directional light, which again is a scriptable object. So because the lighting is all through a scriptable render pipeline, as we can see down here, directional light default under presets defaults, we can actually just select that as the sun source, which is copying the settings from the preset down here. So we have that enabled now. We want to get fog, and we can see we've got a little bit of fog in the distance already. If we disable that, you can see that. But let's actually just go down and select a color of the sky, which just completely fades in the edge of the plane into the distance. Exponential fog type increases the density exponentially based on the distance. So if you're further away, it will be increasing the amount of fog you have. And exponential squared is very similar, but it will happen quicker. So you don't need to go as far to have more of a fog um, starting to appear onto your screen. Uh, it's your personal preference. I haven't investigated the profile to see if there's a difference there. So as you can see on screen, we're starting to see a scene that is starting to look a lot like our previous one. And we have our light probe group, which is here. And if I can create a cube now to understand where we are in the scene, let's move him up, and we can see that our cube is starting to appear. And let's move him towards the camera just a little bit, and we'll put him just there. Okay, cool. So we can see the sun is actually coming up from the corner here. Well, not the sun, but the directional light we're using. And if we select our light probe group, and if we want to ensure that we're getting accurate, we need to reflections and shadows. We need to ensure that our light probe group is actually in here, so then it can actually reference these nodes and project the correct ray tracing of light to the objects well, during baking anyway. So let's ensure that we have our reflection probe as well. So if we move our reflection probe a little closer and we click on our little probe here, okay, now let's go over to the box size and make it a little wider, which means that any objects in here, ideally you want to have a reflection probe per room, so then if you got occlusion culling and various other things to worry about. But so I do recommend you use reflection probes and light probe groups to get the absolute most out of your scene, even if it is just a little demo like this. Now if we select this cube, we can see that it's by default got a lit material to it. So let's just create our new material and just call it white. And I am trying to ensure I use URP because you're just going to get purple textures everywhere. Our main camera has now decided to render the tooltip. However, I think the gizmos are slightly too small. There we are. So let's move this white texture onto there, and we can see here, let's just move that down. We're not going to have any reflections. We're going to allow it to receive shadows, and we're going to enable GPU instancing. So cool, we have a cube here that is not really doing much. So we can see it's using real-time shadows, and if we go into our scripts and assign the camera controller, simple camera controller is already assigned as this was the default standard, so let's just click play and have a look. So the scene there just suddenly went dark for no apparent reason. It was a bug. Essentially just make sure this is running the latest build as well. So just disable auto generate and generate the lighting again, and you can re-enable. The light maps weren't correctly baked. So we can see now if we go away, our fog is enabled quite nicely, and we can get nice and close, and we can see that the resolution for the shadow is relatively low. I think it's 1024 just now. One thing that I would like to show though is if you do want to get a little bit more performance, just a quick one would be to make sure that the distance that you're rendering, so we're using medium, the distance for your shadows, they don't need to be a lot. So if you set this to 1, we can see that our camera in the scene just now is just going to set it up in a kind of the default area that we were at. we can see there's no shadows because it's too close. But if we just start bringing it up, we can see, okay, now you can start rendering the shadows. It's only at 12. You don't need to be rendering shadows at 50 distance if you're just using a scene like this. So that will be the end of this, and then I will be sure to put the GitHub repository links in the description along with the Unity package files and UPM files.